Hello students, today we are going to learn about measuring instruments. Measurements are very important in our life. From making coffee to launching satellites, we need measurements, and we are using lot of measuring instruments in our day-to-day life. For example, rulers, measuring tapes, measuring jars, thermometer, voltmeter, ammeter, and so on. In such a way, one of the measuring instrument is micrometer screw gauge. Today we are going to learn about screw gauge. Here you will be familiarized with the parts and working of a screw gauge. Also you can learn how to measure thickness or diameter of the wire, thin sheets and lead charts. The screw gauge is a very small instrument. It can measure very small dimension up to 0.01 mm. Here I have shown a ruler which is marked in millimeter. Let's assume the width of this small rectangle as 1 mm. If you divide this rectangle into 10 sections vertically top to bottom, you will get 0.01 mm. So the screw gauge can measure such a small thickness, that is 0.01 mm. Here we have some more examples. The screw gauge for measuring thickness of a wire in paper and a metal part. Now let us move on to parts of screw gauge. It has a U-shaped frame attached with a cylindrical part. The object will be placed between S1 and S2. The most important parts are here the pitch scale and head scale. Types of screw gauge. Here I have shown two screw gauges with a different pitch scale and head scale markings. Let us start the first one. Please have a close look on the pitch scale. It's marked with 0, 1 mm, 2 mm and so on. And the head scale is marked with 0 to 100 divisions. Now let's move on to the second one. Here we have the zoomed view of the pitch scale. It's marked with 0, next 0.5, 1, 1.5, 2, 2.5, like that it's going, and the head scale is marked with 0 to 50 division. So in the first model, the distance between the two lines is 1 mm, but in the second model, the distance between the two lines is 0.5 mm. Next, working of screw gauge. Let me explain the working principle of screw gauge firstly. It's same as that of a simple screw. For example, while tighten any object on the wall with a screw, it is rotated either clockwise or anti-clockwise direction. The same way, the screw part of the screw is moved to some distance on each rotation, and this movement is measured on pitch scale. Here we need to familiarize about two more terms. One is pitch and the second one is least count of the screw gauge. Look at this image, a screw with rings on it. Rings are known as threads. The distance between the two threads is known as pitch. Therefore, the pitch is nothing but a small distance. So, as well in the case of screw gauge, the easy way to find the pitch is the distance between the two lines, that is 0.5 mm. Here it means it will move 0.5 mm on the pitch scale for one complete rotation of head scale. This is the screw gauge with 0 to 50 divisions on head scale. So, but in the case of screw gauge with 0 to 100 divisions, it will move 1 mm for one complete rotation. So, for the first one, the pitch is 0.5 mm, and for the second one, the pitch is 1 mm. Next, least count of a screw gauge. This is very important slide. Least count can be defined as the minimum value measured by a screw gauge. In other words, it's the ratio of pitch to number of divisions on the head scale. In a screw gauge with 0 to 50 divisions on head scale, the pitch is 0.5, number of divisions on the head scale is 50. So, least count value is 0.01 millimeter. Next we see errors in a screw gauge. Screw cages are easy to use, but before using it, we must check for the zero error. To get accurate readings, the unmercenary errors should be avoided. Here let's study what is zero error in a screw gauge. There are three types of error: zero error, positive error and negative zero error. Once we get errors, it should be corrected. So how to correct the errors? First start with the zero error. If the axis of pitch scale coincides with the zero of head scale, then error is 0. No correction is required. Here n represents number of divisions. Multiplying with least count gives the corrections in millimeter. Positive zero error. If the zero of the head scale lies below the axis of the pitch scale, then the error is positive, error correction is negative. So how many divisions are below the pitch scale axis? So it's 7 divisions. So the 7th division coincides with the pitch scale axis, then the error is plus 7, error correction is negative 7, and it is multiplied with least count to get the value in millimeter. So the correction is negative 0.07 millimeter. The zero of the head scale lies above the pitch scale axis, then the error is negative, error correction is positive. So how many divisions are above the line? So here 2 divisions are above the line. So the error is negative 2, error correction is positive 2. After multiplying with the least count, the correction is positive 0.02 millimeter. So far you have learnt working principle and finding zero errors of a screw gauge. In this part, we are going to calculate the thickness of the given object. It's a two-step process. Step 1, check for zero error and find numbers of divisions to be corrected. Then place the object between the screws and note down the readings. Here the thickness of the given object is calculated with 3 different screw gauges: a screw gauge with zero error, a screw gauge with positive zero error, and a screw gauge with negative zero error. Let's move on to measuring part. This is screw gauge with zero error. Step 1, check for error. The zero of head scale exactly coincides with the axis of pitch scale. So error is 0, correction is 0, and this correction will be added with the total reading. So step 2, place the object and note down PSR and HSR. PSR pitch scale reading, HSR head scale reading. So as per this blue arrow, PSR value is 2 and then the head scale coincidence is 25. This is 25 head scale coincidence, and it will be multiplied with least count to get head scale reading HSR. So 0.25. The total reading is obtained by adding PSR and HSR along with the zero corrections. So we got 2.25, and repeat the measurement several times by placing the screw gauge at different parts of the objects. This is to find the accurate reading. Then take average. See, the average gives the thickness of the given object as 2.25 mm or 2.25 10 raised to minus 3 meter. This is second screw gauge with positive zero error. Step 1, look for zero errors. Here 0 of head scale is 7 lines down from the axis of pitch scale. So error is positive 7, error correction is negative 7. After the inclusion of least count, it is negative 0.07, and these corrections should be subtracted. Then step 2, place the object and note down PSR and HSR. PSR is 2, head scale coincidence is 32. After the multiplication of least count, HSR is 0.32. So here the sum of PSR and HSR is 2.32. After subtracting 0 corrections, it becomes 2.25. So now the thickness is 2.25. This is our total reading. Then repeat the experiment, take average. So the final value, that is the thickness of the screw gauge, is 2.25 mm or 2.25 10 raised to minus 3 meter. Gauge, screw gauge with negative 0 error. Step 1, look for 0 corrections. Here 0 of head scale is 2 lines above the axis of bit scale. So error is negative 2, error correction is positive 2. After multiplying with least count, the correction is 0.02 millimeter, and these corrections should be added with the total reading. Again, the PSR is 2, HSR is 23. The sum of PSR and HSR is 2.23, and add the 0 correction. So the final value is 2.25. This is our total reading. And repeat the experiment several times. Take average. So the final answer will be 2.25 times 10 raised to minus 3 meter, and this is the thickness of the given object. I hope you enjoy this video. Thanks for watching.